Okay. Hello, students. Good evening. How are you? I hope you are doing good. और तबीयत तबीयत भी सबकी ठीक होगी है ना. So here we are with our lecture number 10, uh, geometrical optics. So hi everyone. Okay, let's see who has joined. So Ruchi Nitha is there. Okay, and 5 others. Got it. So here we are with our lecture number 10 of geometrical optics. Make sure the screen is visible to you and I'm audible to you. Okay. Hello, Dhanushri. How are you? Good evening. At least say good evening, yeah. Okay. Okay. So, firstly, we will make sure the screen is visible to you or I am audible to you. If it is so, please give me a yes in the chat box. You can write yes in the chat box. Okay. Hello, Samsung Lab 2. How are you? आते ही हैंड रेज कर दिया. Yeah. Whatever you have in the form of doubt or anything, you can write in the chat box. Write in the chat box. Okay. So firstly, anyone can reply ki screen is visible or am audible, so that I can start the lecture. Okay. Good evening, Dhanushri. How are you? Screen is visible and I'm audible. Just answer this question, na, so that we can start the lecture. Okay. I'm waiting for 1 more minute. Na. Let the student be joined. Na. At 3:05 we will start the lecture. Okay, okay, okay. Got it. Okay, I got your message, Dhanushri. कोई बात नहीं, नेटवर्क प्रॉब्लम है तो क्या. I got your message now. Okay. And thank you so much for the confirmation. So yeah, let's just get started. So here we are with our lecture number 8, sorry, lecture number 10 of geometrical optics. Okay. Or you can say the ray optics. Now, what we are going to do today, this is our geometrical optics, lecture number 10. What is the aim for today? Aim for today is firstly, we will recall some concept learned in the previous chapter. Then lens formula and magnification. Okay. Power of lenses. We are going to describe how to calculate the power of lens and what does it mean. Okay. Deviation by the lens. Like we have discussed deviation by uh, plane mirror, deviation by spherical mirror, deviation by glass slab. Okay. So here we are also going to see deviation by lenses. Okay. Then we are going to see the lens maker formula, and that is it. So firstly, we will recall. Okay. In recall part, in recall, yeah, we have deal in the previous chapter. In the previous section, we have deal with spherical reflecting surfaces. So what are these? Spherical reflecting surfaces are the part of a sphere. Okay. There is a cylindrical rod, you can say, and if I curd it in the form of a sphere at the front, if I curd this as a spherical surface, so this would become the spherical surface. Okay. And we have two types of spherical surfaces, the convex one if you bulge out and the concave one if you bulge in. ठीक है, अगर आप इस तरह की कटिंग करते हैं ग्लास रोड की कि जो फ्रंट सरफेस है इट इज सीकिंग आउटवर्ड, ठीक है, और यू कैन से the radius of that sphere of which this surface is a part of is lying inside the glass, then it is a convex surface. And if the center of curvature of this part lies outside the surface, it will become a convex one. I will draw it for you. This is the cylindrical rod. If we cut this section like this, so the center of curvature lie here, which is outside. So this is the concave one. Okay, concave refracting surface. Got it? And if I cut this surface in a manner कि जो center of curvature है will lie inside the glass surface. This is the cylindrical rod, and if I cut this cylindrical rod in this manner, so the center of curvature of this sphere इसका will lie inside the surface. So this is the convex one. Or by the concept of spherical mirror, you can also remember this is, if this is the reflecting surface, this is called as the convex surface. ठीक है, and if this is the reflecting surface, this is called as the concave surface. ठीक है, and this is also known as, if this side is reflecting, this side is not reflecting, it is known as concave mirror. Same concept is here. And if this side is reflecting and the inner side is not reflecting, then this is the convex mirror. Same concept used. Okay. Now types of, I have done types of reflecting surfaces: convex refracting surface and concave refracting surface. Okay. Now the relation between object distance and image distance. Like we have placed an object on the principal axis of this spherical refracting surface. So what is the relation between the distances of image and object? So in previous lecture, we have done a derivation of it, and it is mu2 by v minus mu1 by u equals to mu2 minus mu1 by r, where mu2 is the medium from where the ray is coming. Okay? mu2 is the medium from where the ray is going. Sorry, जिसमें ray जा रही है, ठीक है, from where ray is going, and mu1 is the medium from where the ray is coming. ठीक है, got it? And in the simplification, I have told you mu1 is the medium of object and mu2 is the medium of observer. ठीक है, because ray कहाँ जाएंगी, ray observer की आंखों में जाएंगी ना. So mu2 is the medium of observer, mu1 is the medium of object. But in every question you are not getting this situation ki they will specify that this is the observer and this is the object. You have to consider it by yourself. So that is why it is very convenient to learn this formula in a manner ki mu2 is the medium from where ray is going, where the ray is going, and mu1 is the medium from where the ray is coming. Okay? R is the radius of curvature. V and U are the distance of image and distance of object. V is the distance of image and U is the distance of object. Okay, I think you got this. Okay. Now in the recall part, the lenses that we have discussed yesterday. What are the lenses? So lens is defined as a transparent medium which is bounded by two surfaces. Okay, which is bounded by two curved surfaces, you must say. Okay, at least one of the surface will be curved. So that structure or that device is termed as lenses, in which there is a transparent medium having some refractive index, and it is made up of glass. Okay, and one property more, one of the surface, at least one of the surface must be curved. Okay, and you will see in general these surfaces na as a part of a sphere, and we have types of lenses on which this surface is a part of parabola. This parabola you have for the JE, and for the JE student it is easiest to know. In the mathematics also you have learned in the conic section parabola. Okay, it is a symmetrical shape but different from the sphere or circle. Okay, so we have two types of lens here. Firstly is the convex lens and second is the concave lens. Now what is a convex lens? The lens which is thin at the corner and thick in the mid portion. ठीक है, तो वो लेंस whose thickness is decrease from this center to the corner. You can see it is decreasing. ठीक है, it is decreasing continuously. So this type of lens is termed as what? Convex lens, or it is also termed as converging lens. And why it is so? Because if we put a parallel beam of light to it, it focus this light on a point, means it converges the light at one point. It is converging the light at one point. So that is why this lens is called as converging lens. Okay, convex lens itself has a three part. First is the bioconvex lens. In biconvex lens, this radius of curvature of this surface, like this surface, and radius of curvature of this surface are equal. R1 is equals to R2. The second is plano-convex lens. Plano-convex lens में one of the surface is plane, having radius of curvature as infinity. Okay, and this is the surface like radius R. One of the surface is curved, and one of the surface is plane. Now this also termed as convexo. This is also termed as concavo convex lens. Okay, got it? Just a second. Huh? Yeah. So this is also termed as the concavo convex lens. Okay. This surface has a radius of curvature like R1, and this surface has radius of curvature R2. In this type of lens, R1 is always greater than R2. Okay. The second part is the concave lens. Concave lens is that middle portion is thin and the corner portion is thick. Okay, its thickness increases when you move from the center to the corner. Okay, this is a diverging lens also. And why it is so? Because it diverges the ray, falls parallel to it. These are the parallel beam of light. So what will this lens do? It diverges the light. Okay, you can see it is diverging the light. So that is why it is a diverging lens. It also has three part. First is the bioconvex lens, in which R1 is equals to R2. Second is the plano-convex concave lens, in which one of the surface is plane and one of the surface is curved. And this is the negative meniscus lens, or you can say convexo concave lens. Okay, in this you can easily see this has lesser radius of curvature, this surface like R1, and this is R2. So in this you can say this R2 is greater than R1. That is why these corners are never going to meet. Okay, but here this corner meeting at a point because R1 is greater than R2. Okay, I hope you are clear with this. Okay, if you have any doubt in this section, you can just write it in the chat box. Now the term related with the lens. First, we will see the center of curvature. What is the center of curvature? Same. We have deal with a spherical mirror. On that section, you also see if this is a mirror, this is the concave mirror. This is a part of sphere, na? And this sphere has a center. This center is termed as the center of curvature for this mirror. Similarly, similarly, this lens is also a part of sphere, two sphere, one of this surface and one for this surface. So these surfaces have two center of focus, C1 and C2. Got it? Because this is bounded by two surface, and every surface, each surface is a part of sphere. So we have two sphere here. So one of the, so we have two center of curvature here as shown in the figure. Okay. Similar way में, if I measure the radius of this, so it is R1, and this for this is R2. Means two surfaces we have two center of curvature and two types of radius of curvature. Okay. Just give me 10 seconds. Na? So sorry for the disturbance here. Okay. Really sorry. So we have discussed that two surfaces are in the lens. So we have two center of curvature and two radius of curvature. Got it? Same. The radii of curvature, curved surface from one lens are called the radius of curvature. Got it? These are the definition on which you do not need to spend so much of time thinking about them. Like, oh wow, what is the radius of curvature? What concept does it involve? So these are some basic term. You just keep this in mind. Okay? What is the optical center? So optical center of the lens is the, if I cut this lens, or let's say this length, if I cut this lens in equal part, so this point from which the normal to this surface and principal axis at 90 degree, this point is termed as the optical center. Okay, optical center. And what is the property of this optical center? Any ray passes through the optical center, moves undeviated. Means it, this ray will not deviate. Okay, like if this is a ray falling on this, so it do not have any kind of refraction, reflection and type of thing. It will move along its path, continue its journey without deviation. So this is the property of optical center. Okay. Next thing is the principal focus. For mirror, it is simple. One of the surface is reflecting and one of the surface is silvered. Okay. So we have reflection from only from one surface. So we have only one focus. But here you will see there are two surfaces that are bound together. So here we have two types of focus. Okay. One is the first principal focus and second principal focus. Now, how to identify them? Okay. So if you try to read this data from book and all, it will definitely confuse you. Okay. But what I'm trying to see, what I'm trying to tell you is just the simplification of all the concept. Na? Okay. In a very simple manner, if you draw a parallel beam of light to the lens, any one of them. So it converges this point. These ray converges because this is a converging lens. So a parallel beam of light after converging, okay, after converging, where it meets at the principal axis, this is termed as the principal focus. And this is termed as the first principal focus. Okay. What about second principal focus? So if the same beam of light you will throw from here, so what does happen? This will converges here at the LHS side of it. So this is termed as the second focus of the lens. Okay, got it? Sorry, this is termed as the first focus and this is termed as the secondary focus, second principle of focus. Got it? I hope you got this. Okay. In similar way, if you try to see this point, so this is a diverging lens, so it will diverge these rays in this direction. If you extend them, so this is the second principal focus of it. And if you put the same ray from here, so after divergence, they will move in this direction. So if you try to extend them, so they will cut here. This is the first principal focus for concave lens. Okay, got it? Now, if you simple of this, if you throw the parallel beam of light from LHS to RHS, there is a secondary focus for convex lens. And if you draw the parallel beam of light from this side, from RHS to LHS, so that focus is termed as the first principal focus. This is the simple definition of it. Okay, got it? I hope you are clear with this. Okay. Now, lens formula and magnification. So these are very simple formula as you have learned in the learn for the mirror. What about the mirror? What about the mirror? Anyone of you remember mirror formula? What is that? 1 upon F is equals to 1 upon V plus 1 upon. And that plus has to become. Okay? Got it? Or I should write it here so that you will get the information. Okay? It is a kind of recall. Mirror formula. It is 1 upon F of mirror, I must say, 1 upon V my plus 1 upon U. So this is the mirror formula. Okay, got it? Now what about the magnification? Magnification for lenses is V upon U. And for mirror, magnification of mirror, what is that? M is equals to minus of V upon U. Okay, got it? It's just a difference of sign. You can also write this magnification of lens in terms of focus. How? How we are going to do that? So ml is equals to V upon U. We know that 1 upon F equals to 1 upon V minus 1 upon U. If you put the value of 1 upon U is equals to 1 upon V minus 1 upon F. Okay, put this here. ml is equals to V into 1 upon U है ना? So we will put 1 upon V minus 1 upon F. So ml here is nothing but take the LCM. So it is F minus V over Vf, and this is also multiplied with V and V got cancelled out. So you have a new formula. ml is equals to F minus V by F. Okay, so you can apply this formula when object distance is not given, only focus and image distance is given to it. Although in terms of, if you try to calculate this formula in terms of focus and object distance, which is pretty much known to us because we can place the object as our desired. Okay, so for that you have to put the value of 1 upon V. So 1 upon V is 1 upon F plus 1 upon U. Okay, now put this in this formula, but in this formula you have V, not 1 by V. Okay, so what you can do here, you will take 1 upon V is equals to, you take the LCM of it, and it is F plus U by FU. So what is the value of V? It is FU by F plus U. So ML here is, put the value of V, FU divided by U into F plus U. U and U got cancelled out, so you have a new formula. I will write it here. ML is equals to F over F plus U. Okay, got it? So you have three formula for magnification. One is this, second one is this, and third one is this. Okay, I hope you are clear with this. If you have any kind of doubt, you can write this there in the chat box. Okay, where F is the focal length, U and V is the object distance and image distance respectively. Okay, V is the distance of image and U is the distance of object. Okay, now the power of lens. Okay, I have also discussed you about the power of mirror, है ना? Again, this is the power of lens. The formula for power of lens is PL is equals to power of lens equals to 1 upon FL, means 1 upon focus of the lens, the focal length of the lens. Okay, for for convex lens, if this is the convex lens, okay, this is the convex lens we have, It converges the ray here. So this is the principal focus of it. So if you measure this distance, it is in the direction of incident ray. इंसिडेंट रे और इंसिडेंट रे की डायरेक्शन में मेजर्ड डिस्टेंस इज ऑलवेज पॉजिटिव. सो द फोकस ऑफ दिस मिरर would be considered as positive, है ना? But it is not like that. Okay. Now, how does it like that? I will discuss it with you. Now, you will tell me what is the focus for convex mirror. Is it positive or negative? Just write the chat box, na? Use a chat box. Tell me. Tell me what is the focus for convex mirror. Is it positive or negative? It is positive because it forms the virtual image. So the focus will be measured from this in the direction of incident ray. The same goes for this. I'm just testing the knowledge of yours. Na? So the convex lens focus is positive. So the power will also be positive. Okay. After first refraction, where it focus the ray, this is the first principal focus of that. Similar way में for concave lens, if the ray is going in this direction, it diverges it. So after first reflection, ray appears to be coming from this point, and this is the principal focus of it. But it has measured in opposite direction of opposite to incident ray or incident. So this focus would be considered, this is the positive one. So this would be considered as the negative one. For concave lens, focus is negative, so power is also be negative. What is the unit of it? Unit of power of lens is diopter. Diopter. And this focus length must be present in meter. If focal length is given in centimeter, so the formula for power of lens would become 100 by f of lens, where fl is given in centimeter. ठीक है? Keep this point in mind. Got it? So this is about the power of lens. Okay. So we have power of equiconvex lens and plano-convex lens, for which we have a plano-convex lens. I hope you have not this point, so I'm removing it from you. Okay. I will write it somewhere. Okay, so no problem. Convex lens. So we have to find out the power of equiconvex lens and plano-convex lens. Firstly, this is the equiconvex lens. For equiconvex lens, equi means equal. So this R1 here is equals to R2. Radius of curvature of this surface is equals to radius of curvature of this surface. Okay. So that lens is termed as the equiconvex lens. Got it? Now, if we try to find out the formula of focus, or sorry, power of this lens, what it should be? What it should be? Okay. So, yeah, because this length has this lens has equal radius of curvature. R1 is equals to R2. This is the optical center of it. Okay. So the power of lens is given by 1 upon FL for this length. Okay. You will see when we derive the lens maker formula, which is our next topic, you will see the how to find out this focal length FL. Okay. So firstly, we will see the lens maker formula. Okay. So this is our lens maker formula. We have to derive it. Okay. Here, this is the object of, this is the center of curvature of this surface. This is a normal and it passes through the center of curvature. So this is, I must say, C1. Or let's say this surface is 2, second surface, so it is C2. Okay. This is this is the normal to this surface, so it definitely passes through the center of it. So this is C1. Okay. This is C1. Now, a ray is coming from this object going in this direction. After first reflection, it bends towards the normal. You can see if it is not bending, it will go in this direction. But since this glass surface has a refractive index of mu L and it is coming from a refractive index of medium M. Okay. So you can say कि mu L, refractive index of glass lens, is greater than refractive index of medium, okay, in which the object is placed. So this ray, you will see it is bends towards the normal. Okay. I hope it is clear to you. It is bending towards the normal. Got it? After this bending, it strikes the second surface, this surface. Okay. And it will also cause the refraction in it. Okay. So this is the normal and this ray is coming. This is the normal. So this ray, instead of moving in this direction, it will move away from the normal, because it is moving from denser to rare medium. So it moves away from the normal. Okay. So if you will focus, if I draw this after the first reflection, if I draw this, if I extend this ray after first reflection, it will move, it will appear to meet here. And this is the object dash. Why I'm writing it at object dash, I will tell you. So for this object, we have a final image here. This is I. Okay. Now, for this surface, for this surface, this ray is responsible for the image creation. This ray. And if you are sitting on this surface, this ray would appear to you coming from this point. You will see this ray would appears to you coming from this point, not from this point. So this point for this surface behaves as the virtual object. Virtual object. Okay, and again this surface after the second refraction from the image here. Got it? I hope you are clear with this. Let me re-explain it. Okay, from scratch, शुरू से. This is the object. This ray is coming from this object. After first refraction, it bends towards the normal. So for this surface, surface number 2, it appears to be coming from this point. If I extend it, it appears to be coming from this point. So this point behaves as the virtual object, virtual object for surface 2. ठीक है, write this. Okay, but the final image we have here, this is the eye. Okay, so you keep this point. This O dash is the virtual object for one, for which surface? For surface 2, not for surface 1, because for surface 1 this is the object from directly from the rays coming na, this would behave the object and this is the actual object for surface 1. But for surface 2, because this ray has moved or bends towards the normal, so for surface 2 this ray would coming from this point, appear to coming from this point. So this O dash behaves as the virtual object for the second surface. Okay, got it? Now we will measure the distance from optical center in any lens. So this C2 is nothing but R2, radius of curvature for second surface. This C1 is nothing but R1, radius of curvature for first surface, this wali surface, this. Okay, I will write it here. This is the first surface and this is the second surface. Okay, this object from optical center, it is at a distance, let's say u, and u is fixed. Okay, let's say this distance from O dash to the optical center is v dash, and distance of image from optical center is v. Okay, got it? So here what we are trying to do, we are applying the, because these are the reflecting surface, and what kind of reflecting surface? Spherical reflecting, sorry, spherical refracting surfaces, and we have learned the formula of them. Okay, outer medium has a refractive index of mu m, lens has a refractive index of mu l. Okay, and mu l is greater than mu m. So for first surface, if you try to apply the formula, what is that formula? If you remember, it is mu2 by v minus mu1 by u equals to mu2 minus mu1 upon r. This is the formula for refracting surface. Now we are trying to apply this for surface 1. Mu2 is the medium from where the ray is, going. रे इज गोइंग, जिस मीडियम में रे जा रही है, दैट इज द मीडियम फॉर mu2. सो फॉर दिस सरफेस, फर्स्ट सरफेस, in which medium the ray is going? Ray is going in lens. So lens is the medium. mu2 has ml. mu2 behaves as ml, in which the ray is going. ठीक है? So this is mu l. What is the distance of image? What is the distance of image? Tell me, what is the distance of image? And tell me the value of mu1 also. Okay. Yeah. So this is mu L minus. Obviously, this mu1 is the medium from where the ray is coming. और रे कहां से आ रही है? रे इज कमिंग फ्रॉम mu m divided by u. U is the distance of object, which is u. We have mentioned here. It is u. ठीक है. Now, what is the distance v? V is the image distance, and this object appears to be as an image. Okay, this is the virtual object for this surface also. Okay, so here instead of putting v, we will put v dash. Okay, equals to mu of length minus mu of medium divided by what should be the value of r? It is r1. R1. Okay, for the first surface. Okay, just give me 10 seconds. Huh? Okay, these are some technical glitches in my network also, so that is why I have to switch off the camera and mic. Okay, and so sorry for that disturbance kind of thing. So let me again explain you how I write this. This mu2 is the medium from where the ray is coming. ठीक है, from where the ray is going. रे कहाँ पे जा रही है? v में, 2 में जा रही है, लेंस में जा रही है. सो आई हैव राइट इट. लेंस को ये रे कहां से आती हुई दिखेंगी? फ्रॉम वेयर दिस रे वुड अपीयर टू लेंस. फ्रॉम वेयर दिस रे appear to the lens, it appears the lens ki this ray coming from point o dash. You will see इस सरफेस को ऐसा लगेगा कि this ray is coming from this point. So that is why I have write it here v dash, the image distance. ठीक है, because after refraction image will be formed na. So this ray would appear from coming from this point. So this o dash point behaves as the image for first surface. And कौन सा image? Virtual image. But for the second surface it is behaving as the virtual object. Okay, this is equation number 1. Now the second equation is for second boundary. For second boundary or second surface, you can say. Let me write it as second surface. For second surface, again we are going to apply this formula mu2 by v minus mu1 by u equals to mu2 minus mu1 by u by r. Okay, mu2 is the medium in which the ray is going. So for second surface, in which medium the ray is going? Ray is going in mu m. Okay, in this medium mu m, this ray is going. Okay, this is the image distance. So what is the distance formed by this second surface? It is I, and it has a distance v from optical center. So we would write as v minus mu1 is the medium from where mu1 is the medium from where the ray is coming. So ray is coming from lens, this surface, and it has a refractive index of mu l. So mu l is the refractive index value of mu1. Okay, from where the ray is coming. U is nothing but the object distance. Now, for second surface, what will be the object? It is O. Is it O or O dash? Tell me in the chat box. Is it O or O dash? For second surface, what should be the value of object distance? Or you can say, you will only tell me ki what is the object for second surface. Is it O or O dash? Tell me, everyone. I'm asking you, every one of you. Please respond now. Then it is going to be a very interactive session if you respond. Okay. So here for the second surface, this ray, focus on this ray. I'm using the laser pointer here. Okay. This ray would appear to coming from this point to the second surface. Okay. So this point O dash will behave as the virtual object for second surface. Okay. I hope you got this. So the U is not U only. It is V dash, because O dash is present at a distance of V dash is equals to, again, mu2 minus mu1 upon R. Mu2 we have considered mu m minus mu L divided by R2. Okay, got it? Add these equation. Add equation 1 and 2. If we add this equation, this mu L by V dash and this mu L by V dash got cancel out. Only term we have is mu m common, 1 upon V minus 1 upon U equals to mu L minus mu m by R1, mu L minus mu m by R1 minus mu L, sorry, mu m, sorry, plus आएगा ना, we have added, but if I take minus common from here, so it will become mu L minus mu m by R2. Any kind of doubt? I have taken minus common. Okay, so it will become mu L minus mu m. So same thing is here. Now mu L and minus mu m is also common from this. So I will write it as mu L minus mu m 1 upon R1 minus 1 upon R2. Okay. Take this mu m and divide this thing on the right hand side. Okay. Or you can say divided by mu m on both the side. So what do we have? We have when we divide this thing, we have 1 upon V minus 1 upon U is equals to mu L by mu M minus 1, because mu M by mu M got cancel out, into 1 upon R1 minus 1 upon R2. Okay, got it? If U is equals to, we are trying to find out the focus now. So focus is that point the ray are coming parallel to the principal axis. So if the rays are coming from infinity, so infinity से जो भी ray आती हैं, I have told you in the very first lecture of this chapter, when the ray coming from infinity, they will appear to be move in a straight line parallel to the principal axis. So these rays are coming from infinity. They will focus, the lens will convert them onto the focus. So for the ray coming from infinity means object is at infinity and the image will be formed at the focus. So put this value in this equation. So this will become 1 upon f is equals to 1 upon u is 1 upon infinity and 1 upon infinity is 0. So it is 1 upon f equals to mu l by mu m minus 1 into 1 upon r1 minus 1 upon r2. Okay. So this is the formula, lens maker formula. You can write this mu L by mu M. I have told you this is the relative refractive index. So what you can do, it is M mu L, refractive index of lens with respect to medium. You can replace this value and make it single. So this is the lens maker formula we have. Okay. Have any kind of doubt, you can ask. Got it? Now moving on to the previous slide, this power of lens of equiconvex lens and plano-convex lens. So for equiconvex lens, we know that R1 is equals to R2, which is commonly equals to R. Okay. So what is the formula for focus length? 1 upon f is equals to, let's say mu. I have considered the relative refractive index as mu. Outside is air, so mu L by mu 1. So mu L I have considered m, mu. Okay? So mu minus 1, 1 upon R1 minus 1 upon R2. You have to put the values of R1, R2 according to the sign convention. So 1 upon f figure, mu minus 1. What is R1? R1 is the radius of curvature of this surface 1. It is measured in the direction of incidence ray. So R1 would be considered as positive. But R2 is measured in this direction of reflected rays. So it is considered, R2 would be considered negative. Okay? In the left hand side is negative and the right hand side it is positive. So 1 upon R1, R1 is nothing but R, minus 1 upon R2 is nothing but it is also R, but the negative one, minus R. So minus minus will plus, 1 upon f is equals to mu minus 1 by 2R. So this is the value of focus. Now what is power of this lens? Power of equiconvex lens is equals to 1 upon f of lens, and it is nothing but mu minus 1 divided by 2R. So this is the power of equiconvex lens. What about the power of lens of plano-convex? This is the plano-convex lens. Plano-convex lens. Okay? This is the surface 1. This is the surface 2. Surface 1 has a radius of curvature R1. Surface 2 has a radius of curvature R2. What is the value of R1? I have told you. It is infinity. And what is the value of R2? It is R, but it is measured in the direction of reflected ray in the LHS side. So it is minus R. We have formula for focal length. F of L is mu minus 1 in general, 1 upon R1 minus 1 upon R2. What is the value of R1? It is infinity. So F of L is equals to mu minus 1. 1 upon R1 is infinity. So 1 upon infinity minus minus plus 1 upon R. So it is FL is equals to, 1 upon FL. 1 upon FL. 1 upon FL. 1 upon FL. So it is mu minus 1, 1 upon R. the power of lens of plano-convex PC is equals to mu minus 1 divided by r, because it is 1 upon. Okay. From the previous case, it is twice. For equiconvex, it is mu minus 1 upon by 2r, which is power of plano-convex lens divided by 2. So the power of equiconvex lens is half of the power of plano-convex lens. So instead of using equiconvex lens, we should use plano-convex lens for higher power. Okay. Okay. So what do we have? Deviation by lens. It is a very simple concept. So this height you would consider h. This ray should go in this direction if this lens is not present. So it has deviated from its length at an angle of delta. Okay. This is the image form here. Okay. Now this ray is parallel to the principal axis. So it converges at a point of F. This is the focus length of it. Okay. So this is the deviation of it. If you apply, you will consider this as a triangle. You apply tan delta. So what is the value of this angle will behave as delta. So tan delta is nothing but this distance is h and this distance is f. So perpendicular upon base h upon f. So rays are rays are paraaxial. Paraaxial. So this tan delta approximated as delta. So delta is equals to h upon f. This is the formula for deviation. Okay. I hope you are clear with this. So this is it from my side. Thank you so much for attending the lecture. Okay. If you have any kind of doubt, you can ask. This is it. Thank you.